I'm doing this video on phase and phase difference because sometimes these two terms can be a bit confusing. And what I'll do is in the first video on this, I'll focus on phase and probably touch upon phase difference. And in the next video, talk about phase difference in more detail. So let's focus our attention on what the phase is. And to understand what phase is, what we need to first understand is how a wave is formed. Because if we develop that understanding well, we'll be able to understand phase far more easily. So what I'm going to do is I'm going to first explain to you how a wave is getting formed. So let's say this is a medium, and I've taken a medium with a boundary over here, and we'll try to understand how a wave is formed. You know that a wave looks something like this. If I take a wave moving along the positive direction of the axis, the wave goes like this in this direction. So how is this wave formed? That's what we're trying to understand. So let's say this is a medium, and let's say these are the particles of the medium. Let it be air. So these are all air molecules over here inside this space. And let's say at this particular location, a vibration is introduced. So this will set off a motion in the molecules over here. And to keep matter simple, we will focus on the particles which are there on the x-axis. So let's say this is the x-axis, and there are particles on this. These particles will be very, very close to each other. So there's particle 1 over here, which is over here. There's particle 2 over here, which is very close to it. And that goes on. For again, to make matter simple so that we are able to draw a diagram, what I'll do is I'll take particle 1, I'll take particle 2, 3, 4, 5, 6, 7, and 8. So these are the 8 particles that we are looking at. So let's go back over here. A vibration is set up over here, and what is observed is the first particle starts vibrating. So it will go up and go to its maximum amplitude. So I'll show now the amplitude. I'll draw a line for amplitude. So let's say this is the line of the amplitude, and of course that line will be on both the sides. So let's say this is the line of amplitude I've drawn over here, and this distance that we see over here, this distance over here is this distance is the amplitude A, and this is distance is, I can call it minus A because it's on the negative side of the y-axis. So again, coming back over here, the first particle goes up, will go to its mean position, come back over here, go back over here, and start oscillating like this between across the mean position between these two extreme points. Now the fact is, this particle starts oscillating first, and after a time lag, which would be very, very small, the second particle will start oscillating. Once again, this particle is actually very, very close over here, but to help our drawing, we have shown it at distances over here. Now, so let's say this first particle has reached over here at this extremity, and at that particular instant, the second particle starts moving up. So this will start going up when this particle is over here. So what will happen is when this particle reaches over here, this starts going up, and when this particle comes back over, this particle would have reached over here. And let's again say that when this particle reaches over here, the second particle starts. So when the second particle reaches over here, the third particle would have moved over here. And this is what happens throughout. And that is what introduces what we will later on discuss as the phase difference between these particles. So let's say that we are now looking at eighth particle. This is the eighth particle, and let us say it has gone up and has come back over here. So it has covered a distance of, as far as the eighth particle is concerned, it has covered a distance of 2 times amplitude, because from here to here is 1 amplitude A, and coming back over here is 2 times amplitude. So let's say it has completed 2 amplitudes of motion. And we also know that 1 amplitude motion is equivalent to pi by 2. one amplitude is equal to A is equal to, if a particle moves, its angular measure is pi by 2. And let me explain that very quickly over here. So if you look at simple harmonic motion as the motion of a projection of object performing circular motion. So the object is moving like this and its projection oscillates back and forth between these one positions. So when this particle goes up over here, the angular distance covered is angle covered is pi by 2. So when it covers pi at the distance equal to amplitude, this is equal to pi by 2. And therefore we say this angular is equivalent is pi by 2 radians. And therefore particle 8 angular distance covered is 2 into pi by 2. And that's equal to pi. And therefore, and this pi is known as the phase of the particle. What we are referring to over here, this phase of the particle is this. What information does it give me? It tells me the phase is pi. And what I know from this is that phase, if it is pi, I can write it as 2 into pi by 2. And that would mean 2 amplitudes motion. So I know it has started from the mean position, gone here and come back over here. So it tells me how many amplitude motion the particle, that particular particle has covered. Not only that, it also tells me that since it has started from here, gone over here and come back over here, it will further move downwards in this direction. Because when a particle is at the mean position, it could be going up or it could be going down. So this phase tells me two things: the location of the particle between these two limits of amplitude and where it will be moving next. So we say that this particular particle has completed 2 amplitudes. This particle would have completed obviously 3A amplitude, because we are saying that all particles are, the differences between them is 3A. A bit is only 1 amplitude. So if this has completed 2 amplitude motion, this would have completed 3 amplitude motion. So that would mean this particle would have started from here, gone over here. So 1, back here 2, and back over 3. So the particle 3 would be over here. Remember, particle 7, sorry, this is particle 7, this is particle 8. 8 particle is over here, 7 particle is over here. And this is the location of 7th particle. 6th particle would have covered 4 amplitudes. So start from here 1, 2, 3, and 4. So it's back over here. So I have this location of these 3 particles. And what is the phase of this particle? It has completed 1, 2, 3, 4, 4 amplitudes. That means 4 into pi by 2. That will be 2 pi. So this is 2 pi. The phase of particle 6 is 2 pi. And that tells me also not only the location, but it also the direction. So what does it mean by 2 pi? So again, if I can do the same exercise, 2 pi can be written as 2 into pi by 2 into 2. So I have multiplied and divided by 4. That will give me 4 pi by 2. And 4 pi by 2 means 4 amplitude motions. So start from here 1, 2, 3, 4. Finally, I have reached over here from this side. That means this particle now would be moving in the upward direction. And you can see the difference between these two. Both of them are at the same location, but because I know the phase, I know where it will move next. So we can do the same thing over here. This is the 5th particle, and it would have, if this has covered 4A, this would have covered 5A. This is the 6th, this is the 4th particle, this is 6A, 3, 2, the first particle, 7A, and this is 8A, and this is 9A. And let's now come back over here. What is 9A? That means the particle started from here, gone over here, 2, 3, 4, 5, 6, 7, 8, and 9. That means this particular particle is over here. And by using the same logic, we can find out that if this particle is over here, this particle would be over here, this particle would be over here, this over here, and this particle would be at this location. And so if I'll draw a line joining the locations of this particle at this particular instant, I'll get something like this. Something like this. And this is how a wave is formed. And this is how we understand phase of a particle. Please note that this particular wave that we have shown is the snapshot of a wave at a particular instant. This wave is actually moving ahead. And if you look at an actual wave, you'll see it moving ahead. But in this case, what we are seeing over here is the snapshot or the picture of the wave at a given instant, say t equal to 0.12 second, for example. And if I look at this wave at the next second, say at 0.13 second, I'll see that these particles have moved, they changed, and the shape of this wave will be slightly different from what it looks at this particular instant. So in this video, I have shared with you how a wave is formed and what is phase. And in the next video, we will look at phase difference in more detail. Thank you.